Welcome. So in this video we will learn about the principle, procedure, reactions involved and the calculations involved during the determination of peroxide value of K. So peroxide value, first let me tell you that peroxides are the primary reaction products. So they are the primary reaction products formed during the initial stages of oxidation, and therefore peroxide value gives an indication of the progress of the lipid oxidation. So we know that when oxidation starts in any oil sample, then first the primary oxidations or products are produced, which are nothing but the peroxides and the hydroperoxides, and then these peroxides and hydroperoxides during the secondary stage of the oxidation get converted to aldehydes, ketones, alcohols, and some volatile acids are also produced. And these are the secondary oxidation products, and these will impart the flavor to the ghee. But in this test, we are determining the initial product of the primary oxidation, that is initial product of the oxidation, which are the primary oxidation products, peroxides and the hydroperoxides. So this method is applicable for determining the peroxide value of milk fat, ghee, butter oil, anhydrous milk fat, and anhydrous butter oil. So any type of the sample we can determine the peroxide value. So the usual method of assessment of density in ghee is by determination of peroxide value, which is reported in milliequivalents. The unit is milliequivalents of peroxide oxygen per kg of the fat, or we can also express in the form of 0.002 normal sodium thiosulfate per gram of the sample. So whatever unit we are using, so depending on the value we are getting, we have to interpret to which category our sample is falling, to which grade our sample is falling as per the standards. That will depend on the unit of the sample which we are unit of the peroxide value which we are taking. So the most common method for peroxide value determination is based on iodometric titration. So in this, iodometric titration is involved. So this means that we have to titrate it with sodium thiosulfate. Iodine will be releasing. So which measure the iodine produced from the potassium iodide by the peroxides present in the fat or oil. So we know that we have peroxide formation which is happening during the initial stages of oxidation. So this peroxide react with us. So we can see the reaction that release the iodine from the acidified Ki. So this is acidified, that is acetic acid we are using, and Ki we are using. So this is, we can call it acidified Ki. So peroxide release iodine from the acidified Ki in the first part of the reaction, and this iodine is then titrated with sodium thiosulfate using starch as indicator. So initially there will be clear blue or blue black color will be obtained, and then we will be titrating using sodium thiosulfate using starch as indicator until we are having colorless endpoint. So we will have the production of sodium tetrathionate at the end. So this is sodium tetrathionate which has been produced. So these are the reactions which are involved. This is the principle which is involved during the determination of peroxide value of Ki. Again repeating, so peroxides can release iodine from the acidified Ki, and this the iodine which is released is titrated with the sodium thiosulfate in the second part of the reaction using starch as indicator. So initially color will be blue black, which will convert it to colorless endpoint. That titer value which will be obtained, that will be applied in the formula that we will see in the coming slides. Now what are the reagents are required? I told you we need acidified Ki. So we require acetic acid, and the chloroform solution is required in this. So mix 3 volumes of acetic acid with 2 volumes of chlorophyll. So chloroform is acting as solvent. So 3:2 ratio of the acetic acid, glacial acetic acid, and the chloroform mixture is to be prepared. Then we have to prepare the saturated KIU. So dissolve KI in freshly boiled water until no dissolution of KI take place. So saturated KI we have to prepare, and also we have to prepare standard thiosulfate solution. That may be 0.1 normal we can prepare, or 0.01 normal depending on the peroxide content in the sample, or depending on the storage, or depending on the how much density has been taken place in the sample. We can prepare 0.1 or 0.01 normal standard sodium thiosulfate solution. Now this standard sodium thiosulfate solution we have to always standardize with potassium dichromate. That is nothing but a K2Cr2 0.07. The potassium, this we have to standardize with potassium dichromate. So dissolve around 24.8 gram of sodium thiosulfate crystal in distilled water and make up the volume to 1000 ml to obtain 0.1 normal, and then we will standardize it using the potassium dichromate. Now let us see the procedure. Simply you have to take 5 plus minus 0.5 gram sample in a 250 ml glass topped Erlenmeyer flask, and then you add 30 ml of the acetic acid chloroform solution and salt to dissolve. Okay, then initially first you take 5 gram or 5 plus minus 0.5 gram of the sample in a 250 ml glass topped Erlenmeyer flask, and then you add 30 ml of acetic acid chloroform solution and salt to dissolve. Then you will add 0.5 ml of the saturated KI solution for more pipette, and then let it stand up with occasionally shaking for 1 minute, and then you add the 30 ml water, so that iodine can be released from the acidified KI, which will be released by the peroxide. So peroxide in sample will release the iodine when you are making keeping it for 1 minute, and then you have to add 30 ml of water, and then you finally titrate with 0.1 normal sodium thiosulfate solution with rigorous shaking until yellow color is almost gone, or the yellow color is because you have added then if yellow color is there, otherwise if this you want to skip this step, then you can add 0.5 ml of the starch solution and continue titration by shaking vigorously to release all iodine from the chloroform layer until blue color disappears. So if you add the starch solution, then you will have the blue color or blue black color. This is because the starch, when react with iodine, you will have the blue color or blue black color. So you have added 0.5 ml of the starch solution and continue titration by shaking vigorously to release iodine from the chloroform until blue color disappears. So if you see that this step is if you don't want to this step can also be skipped. You can directly add the starch solution, and then you will have the blue black color, and then you will titrate to the colorless endpoint. If less than 0.5 ml 0.1 normal sodium thiosulfate is used, this means more of the peroxide is there in the sample, then you can also prepare 0.01 normal sodium thiosulfate, and then you can obtain the titrate value. And then in this case you have to also remove the subtract the blank you also have to determine and that is to be subtracted from the sample titration. In blank you won't take the sample. Now peroxide value expresses milliequivalent oxygen per kg per of oil equal to the titer value into normality of the sodium thiosulfate used into 1000 and to weight of the sample. So this is very easy to derive. We know that the number since this is expressed as peroxide milliequivalents of oxygen per kg of the oil or per kg of the sample, so milliequivalence is there. So we know that the definition of equivalence is number of gram equivalent of solute present in per liter of solution. Number of equivalent of gram equivalents of the solute number, if you see, if we write it in this way, number of gram equivalent of solute present in 1 liter of solution, that is nothing but the a number of equivalents. Okay. And if we see apply the formula, that is normal equation N1 V1 equal to N2 V2 here like this. So here in this side, if we are taking sodium thiosulfate, and in this way side we are taking peroxide oxygen, so here N1 will become N2 divided V2 divided by V1. So since we are taking a weight of the sample, so here we can write W. Okay, so this normality has comes, and this titer volume has come here in this formula. And then normality means here since we have to express in milliequivalents of oxygen per kg of oil, so equivalents will be so this equivalents will be this number of equivalents, this is number of equivalents, and then since you have to calculate milliequivalents, then we have to multiply it by 1000. So here we will multiply this by 1000 to have the milliequivalents of oxygen, and since this is already in kg per kg of the sample, so this will be the equation. This will you obtain that peroxide value equal to milliequivalents of oxygen per kg of the oil. So this way we can derive it. So since we are expressing here at milliequivalents of oxygen, so we put here that this is the equivalent of oxygen, and then milliequivalent will be, we have to multiply it by 1000 to obtain the milliequivalent of oxygen per kg oil. Now, as per AOC, that fresh soils usually have peroxide value well below 10 milliequivalents of peroxide oxygen per kg, and rancid taste often becomes too noticeable when the peroxide value is above 20 milliequivalents per kg, and that ranging between 2 up to 40 milliequivalents per kg. So above 20 milliequivalents per kg, if peroxide value is obtained, then we will declare that the sample is rancid. But I has already told you that peroxide value can also be expressed in volume of 0.002 normal sodium thiosulfide per gram of the fat, and if this unit we are using, this way we are calculating, then the peroxide value categorization or grading will be like this. That is, if less than 0.5 is obtained, then we'll say that it is very good. 1.6 to 2, then it is good quality. 2.1 to 2.5, it is of fair quality. 2.6 to 3.5, poor quality. 3.6 to 4, then it is not acceptable. So we can, depending on our result, we can categorize the sample as very good, fair, poor, not acceptable, depending on the peroxide which is obtained in the sample. So this way we are determining the peroxide value of ghee. So in this video we have learned about the procedure, the reactions involved, calculations, and also the interpretation of the results which are obtained from the determining the peroxide value of any sample. Thank you.